Hello and welcome back to our continuation of AWS Solution Architect Associate level. We are continuing with VPC, Virtual Private Cloud. In our last lesson, we saw what VPC was all about. We created a subnet, or we actually created two subnets, a private subnet and a public subnet. And I told you people how to differentiate between a private subnet and a public subnet. In fact, how to make a private subnet becomes a public subnet. I informed you, I showed you how to do that. Then we created an internet gateway, which I told you what an internet gateway is all about. A route table, we did create a route table. Now what we did not do was NAT gateway. We didn't do NAT gateway, and we are going to continue today from NAT gateway. We did a bastion server. You still understand what is bastion server is all about. Okay, so for today, our continuation is going to be with network access control list. We are going to do our network access control list, and we are going to do a NAT gateway. NAT gateway. Let us write NAT in full. That should be network address translation. So you will see what NAT does. NAT gateway. So we'll begin from NAT gateway, then we'll go to NACL, network access control list. Then we'll see what ephemeral ports are. We'll see what deny rules are and what rule numbers are. And then we'll do VPC peering. And this is one of the most important part of VPC. We'll do VPC peering and see how we can pair two VPCs together. So without much explanation here, let's hit over to our console and start with network address translation. Before we enter network address translation, I am going to take time and create all the infrastructure. I'm going to create all the infrastructure from scratch, and I'm going to be very fast because I've already taught you guys on how to create all that infrastructure. So you just follow with me as I create the infrastructure. This is our AWS console. I'm going to start by creating a VPC. So for those of you who might not know where to reach before you create your VPC, you come to services, and then from the services you can type VPC here and search. All right, you can type VPC. You get your VPC here. Then you click on your VPC. And when your VPC comes, you start creating your VPC. So this is how it will come, this is how it will look like. Okay, I create on my VPC. There's always a default VPC, as I told you. So we start by creating our VPC. If you are on VPC and more, choose VPC only. Okay, I took time to explain to you. We are going to create VPC -1. I took time to explain to you. This is sidecar numbers. I hope you still remember them. The first one is 10 point, we take 10.15.0.0/16. we create our VPC. The next thing we are going to do is we create our subnets inside our VPC. First subnet that we are going to create is going to be, let us be writing everything we create. This is infrastructure, as I told you. So VPC1, it is 10.15.0.0/16. Then we are going to create private subnet 1, which is going to be 10.15.1.0/24. okay, so we copy this address, then we go to create subnet. We are creating the subnet inside VPC1. Then the subnet name is private subnet -1. So for availability zone, I choose 2A, and then for CIDR, we paste our CIDR block. We already know why we are doing all this, and then we create our subnet, our private subnet. Next is we are going to create a public subnet. What is the name of our public subnet? We will have public subnet -1, and what will be our CIDR there will be 10.15.2.0/24. so we copy our CIDR. Now we come here, we create our subnet. We are creating it in VPC1. Then we come down to our subnet name should be public -subnet -1, and we should create that in 2B. Then we come down, we paste our CIDR block, and our public subnet is created, but we need to go and make it public. We have just created it. When you create it, by default it is private, so we need to make it public. We select the public subnet, come to actions, edit subnet settings, and then we click on enable auto assign public IP4, and then we save. Our public subnet is now public as we want. Okay, the next thing is we create a server, a web server inside our public subnet. So come to EC2 instances, we launch an instance. We call our instance web server -1, and then we take Ubuntu, and then we come down to our instance type is T2 micro, is okay by us. Select our key pair here, have my key pair ready, and then we decide where we are creating our EC2 instance. We want to create it in VPC1, and we want to keep it in public subnet. It is a web server, so it should be in public subnet. Then we go right down, and then we create a security group for it. Okay, web server security group, and the same thing, description, web server security group. Okay, now our security group should have SSH open, and also since it is a web server, we are supposed to open HTTP. So we add security group rule, and then we open HTTP, which is port 80, custom to anywhere. It's a web server, so it can be anywhere. So we can create our web server in the appropriate place now. Okay guys, our web server is created. Can we access this web server? Definitely we cannot access this web server because we have not yet created any internet gateway, and we have not yet created any NAT gateway. So by that, we are unable to access our web server. We practiced this last time. So let's go ahead and create. Let me bring you our physical is this the one? Yeah. So we are here. We have just created our VPC. This VPC like this, we have just created it. We have created these two public subnets, and then we have created this particular EC2 here. This is the EC2 that we have created. So we have not yet created neither this route table nor internet gateway. So there is no way we can access this particular EC2 instance that we have created. Okay, there is just no way. So in order to access this instance, we have to create a route table and create an internet gateway and link all the two of them. Let's go create that. Let's start by creating an internet gateway. We come to internet gateways. To come to internet gateway, you just come to your VPC. Under your VPC, you see internet gateways here, and then you create internet gateway. We are going to put it VPC-1-internet gateway. That's the name of the VPC, of the internet gateway. We have created it, and then now we link the internet gateway to our VPC. The internet gateway is now attached to our VPC. Now the next thing is we create a route table. Go to route tables, and then you click on create route tables. We call it VPC1 route table, and we are creating it inside VPC1. Always make sure that you choose where you are creating your resources. Create our route table. Our route table is now created. We join the route table to the subnet that we want. So we are going to link it to the public subnet. That's where our route table is being linked, because internet should be entering only to the public subnet and not to the private subnet. Okay, after we link it to the public subnet, we link it now to our internet gateway. So we add routes, and then we choose internet gateway here, and then we take it to the internet, and we choose our internet gateway. We save. Now we can successfully access our computer if everything is okay. Let's try and see if we can get access to this EC2. Let's first of all go to our EC2 instance, our web server, and then we see if our web server is already running. It's already running, so we try to connect. SSH connection, copy that, and we come to make sure if our EC2 instance is having a public IP address. let's see. Yeah, our instance is having a public IP address. Definitely we can connect. Okay, we open git bash. And we paste. We are able to connect. Good. Now let us update our instance. And then while our instance is updating, let us install Apache server. Let me think. Yeah, this is a script for the installation of Apache server. We save and we quit. Now we execute our Apache shell. So at this moment our server is being installed and it has restarted. So now let us see if our server is on. We copy our IP address and we paste. Okay, our server is on. Welcome to VPC Studies. Our server is on. All right, now that our server is on and everything is functioning well, let's see. We have done this and we have installed our server and our server is on. The next thing that we want to do is we are going to create a database here, and then we create a bastion to get access to that database. Okay, and then when we create that bastion, I'll get access to that database, and then we'll cover all of them with a network access control list. That is where we'll start our studies. So let us create a database, create a bastion, have access to our database. Okay, we continue. Now we are heading to create a database. Database name VPC-1 DB, and we take Ubuntu. T2 micro is okay for our demonstration. We just take the same key pair, and then we make sure we edit where we are creating in VPC1, and we are creating in a private subnet which is already selected. Auto assign public IP is disabled. Remember that here you always need to create a new security group for each VPC that you are creating. So this is DB security group. Now we just need only an SSH for our security group and nothing else, so we can create our security group. Okay, our DB is created. Now the next thing is we have to get access to this DB. So but in order to get access to this DB, we have to create a bastion. So let's go and create a bastion. Let's create a bastion. Let's just name it bastion. Somebody asked me if we must name it bastion, but we should not always name it bastion. Bastion is a cloud nomenclature. You can name it anything. T2 micro is okay for our bastion, and the key pair of our bastion. Our bastion should be found in VPC 1 and in the public subnet, and our bastion should have its own security group, bastion security group, bastion security group. And now our bastion should be connected by SSH. Yeah, but is it from anywhere? I don't think so. Let me just put my IP. Bastion should be connected only through my IP. Remember what we said, the bastion give access to the bastion only to the particular database engineer. Remember we said that. So we launch. Good, our bastion is created. Now here is where we are. We have created this database and we have created this bastion, right? So we have to log into this bastion, and then from this bastion we get access to the database. Here is what we are going to do in order to do that. In order to log into this bastion, we have the key. Okay, we have the key pair. Now, but in order to log into this database, the key pair that we have cannot log directly to the database, so we have to create a key pair of this database and transfer it to the bastion before we are able to log it. Look at what I'm trying to say. Now when we open git bash here, we are able to log in git bash here because git bash is open where the key pair of this machine is found. Git bash is open there. But now if we are found inside this machine, inside this EC2 instance, the key pair of the database is not located inside this EC2 instance. Can I try to draw it for you to see? Let me try to demonstrate it for you. This concept actually worried me somehow, so let me try to make sure I clarify you very well. So you guys should take a look at this. Let us try to do some demonstration here. Okay, this is my laptop. This is my laptop here, right? Okay, in this my laptop, there is a key pair inside my laptop that permits me, this key pair permits me to log into my cloud computer. It is through this key pair that I am able to log into my cloud computer. So this key pair is a key pair of which computer? This key pair like this is a key pair of this computer, of this cloud computer, but the key pair is found where? In my laptop. So I have this key pair in my laptop. I can use this key pair in my laptop to log into this cloud computer. So here is this one is my laptop, right? And this one is EC2 1. Okay, now this other EC2 1 like this is its own key pair. EC2 1 has key pair. This is a key pair for EC2 1. Okay, the key pair for this machine is found inside my laptop. Now we have another machine. Now there is another machine in the cloud. Again, it's another machine in the cloud that has its own key pair, but the key pair to this machine in the cloud, we have it inside our computer here. We have it, that key pair inside our computer here. EC2, we have that key pair here. Now the problem is, for you to log into an EC2, you must have the key pair in your machine. Now, but we have already logged into this EC2, so we are inside this EC2. Now we need to log from this EC2 to this one. So for us to log in from this EC2 to this one, we need the key pair of this EC2 to be found inside this other EC2. That means we need this key pair for the EC2 1 to be found here. When the key pair is found here, now we can use this key pair and log into this one. This is now EC2 2. EC2 -2. So we need the key pair for EC2 -2 to be inside EC2 -1. I hope the concept is clear. We need the key pair of EC2 2 to be inside EC2 1 so that we can log in. The key pair of EC2 1 is found inside my laptop, but the key pair of EC2 2 is also found inside my laptop, so I have to transfer it from my laptop to EC2 1 so that I can be able to log in now from EC2 1 to EC2 2. Okay, so now it happens that I am using one and the same key pair, so I'm using the same key pair, so I just need to transfer this particular key pair from this machine to the cloud machine, and then I use it, I log into the second key pair. But I'm not going to transfer it. I'm going to show you a different method because we are going to use that method in our advanced course. I'm going to recreate the key pair. How will I recreate the key pair? This key pair like this has a name and it has a content. Okay, so if I create a file inside this machine and give the file the same name, and then I copy the content of this file and I paste inside here, then the file inside here will have the same, everything will be the same. So I have created a new key. You get the point? This key has a content. It is a file. The file contains something, right? And there is this name. So if I can just create a file inside here and name it the same name, and then I copy the content that is inside this file, I paste it inside this one, it will be the same thing that I've created. Okay, that is the technology we are going to use. Okay, follow up and see how we are going to do it. So I'm getting short of screen. Okay, the first thing we are going to do is we want to create a key pair here in EC2 1. We are creating the key pair here. Okay, so in order to create that key pair, we just simply write vim, my key pair name is airfrance.pem, right? This is my key pair name. I'm creating a file, and the file name should be the same like my key pair. Okay, airfrance.pem, and then I open now the file. What do? I just simply come to where that particular file is found. This is the key pair here, right? I open the key pair. It is my private key, so I open the key. I'm going to try to open the key with a Notepad++, please. Okay, here is the key. You see that the key has a content. So what I'll only do is I copy everything inside this key. Let's copy everything inside this key, and then I paste it inside the file that I just created. Good. You see the key is pasted. I save. Now if I run ls, I have my key pair inside here, right? The same key pair, I have it inside here. So what do? I have to change the permission of the key. .pem. Now the permission has been changed. Now from here, I can move from here to my DB, which means I am able now to move from this bastion to my DB. Okay, that is what we are doing. So let us move. Were we in the bastion? Let's enter the bastion, please. We copy the key to our web server. So let's go to our bastion. Okay, we update our bastion. Then we create our key in our bastion. Then we paste the key in our bastion. Then we change the permissions of the key. In our bastion. Now we can go now to our DB. Let's go now to our database. Here is our database, and then we connect. We take our connection from our database, and then we try to see if we can cross over from our database, from our bastion to our database. And we did cross. Good. We have now crossed from our bastion to our database, so our bastion is saving its duty, which is okay. Now we are in our database. Okay, we did say the first thing we want to do is study NAT gateway, right? NAT gateway, that's the first thing we want to do. We just updated our bastion. Let us try to update our database. You see our database is at 0% here, right? The update is at 0%, so nothing is happening, nothing would happen, nothing will occur. Why is nothing happening? Because our database is found in the private subnet. This is the private subnet, okay, and there is no internet access entering the private subnet. So what is the role of NAT? What is the role of NAT? So when you hear about NAT, they say it is a network address translation. What NAT does is that NAT will simply come now. It will provide internet to be entering inside this database, but the outflow of internet from this database, this NAT gateway will translate this IP of this particular computer so that nobody out here can be able to reach this computer out here. The computer out here will be able to go out to the internet and download things, but nobody out of the in the internet can be able to get into the computer, into the database. Okay, so the NAT gateway gives only one direction flow, and the direction is from the database to the internet. It will only flow from the database and download things from the internet, but nobody in the internet can have access to the database. Okay, that's how NAT is being that's how NAT functions. And NAT has a cost. When you are creating a NAT gateway, it comes with a static IP address. If you delete the NAT gateway without deleting the static IP address, AWS will keep on billing you. Your bill will keep on multiplying. So whenever you delete a NAT gateway, you must release the static IP address. Okay, you must release it. The elastic IP address, not the static, the elastic IP address, please. So each time you delete NAT, you should release your elastic IP address. Okay, comes with an elastic IP, not a static, elastic IP. So a NAT gateway to operate in a private subnet is created in a public subnet. Get this very well. Hear this again very well. A NAT gateway to operate in a private subnet is created inside a public subnet. So we create a NAT gateway inside a public subnet. But how do we make it available to the private subnet? We create a route table and link the route table to the private subnet, and then link the route table to the NAT gateway. So the NAT gateway is created inside the public subnet, links a route table, and then the route table links the private subnet. That is how it is being done. So let's go see if our system finally updated. No updating, failed, connection 101 failed, nothing function. Okay, everything failed. So but absolutely we need to update our database. So in order to do that, what should we do? Let's go create a NAT gateway inside our public IP address, inside our public subnet. So we come to subnets, come to NAT gateway, please. NAT gateway is found inside the VPC console. NAT gateways, we create NAT, name of NAT VPC -1 NAT gateway. The subnet should be the public subnet. Then allocate elastic IP address. You should click this one. Okay, allocate elastic IP address. You have to click it, so that you should allocate an elastic IP address for the NAT. That is what makes the NAT payable. You create your NAT. Okay, you see our NAT state is pending. Okay, if we come to NAT gateway, we discover that it is pending. All right, so while it is pending, let's go and create a route table and link it to our private subnet. Private subnet route table. For NAT VPC 1. You can create it, and then we go to actions, edit subnet associations, we link it to private subnet. Good. And then we come to actions, edit routes, and then we link it now to our NAT gateway. And then we expose it now to the internet. Then we save. Good. Now let's see if our NAT gateway is already functional. Our NAT gateway is available now. Let's go and see if we can update now. Now our database is being updating without any problem. So what have we done? In order to send internet access to your database, you should provide a NAT gateway. That's a very important question that is always asked in most of the DevOps interviews. How do you supply internet into a private subnet? The answer is use a NAT gateway. They will follow up the question. Can you explain how a NAT gateway functions? Yes, a NAT gateway functions with a one-sided flow of internet. You provide internet to a resource, but nobody can make calls to that particular resource from the internet. Okay, we call it a DNAT. Okay, so that is it for the NAT gateway. Okay, network address translation NAT gateway. I hope we have seen it very well. Now let us enter into network access control list. What is network access control list? For network access control list, it is a layer of security. Okay, let us see what we are trying to see here. Now we have our VPC. We all know that VPC is a layer of security. Okay, this is your VPC. Now when you have your VPC like this, you have the first subnet and then another subnet. Okay, you can prefer that on top of this subnet you want again to add another layer of security there and block the subnet with it. Why will you do that? Because this other subnet, this other layer of security that you are adding on top of this subnet is intelligent more than the subnet. This layer of security, you can use it and say that in this particular layer of security, I want to block this particular IP from entering. I want to block this particular person from entering this particular subnet, or I want to see everybody that is entering this particular subnet because of this layer of security. So this layer of security is some sort of intelligent, it is smart, but the subnet itself is not smart. So in order to control access into and out of the subnet, you need what we call a network access control list. Okay, so that is a layer of security that is given in your around your subnets. Okay, so let's go see how we create this network access control list. So you just come to network access control list. Your VPC panel has nearly all of these things, so you just come there and you search for all of them. You should see under network firewalls. Is it under network firewalls? Let's check. Network under security, it comes under security, network access control list. So we create our network access control list. By default, 2 of them are created, but they are accepting all rules. Now, as of now, look at something. We can have access to our web server. Okay, take a look at where our web server is found. Our web server is found here, and we want to put a network access control list inside this around this particular subnet. That means we are going to block our web server from getting access to it. So the moment of truth will be when we will finish putting this network access control list. We are going to see if our web server is still available. If it is still available, then it did not work. Okay, so let's go put our network access control list. So we create a network access control list. We call it VPC 1 NAC. And then we put it under VPC 1, and then we create. After we create the NAC, we click on the NAC, go to actions, and then now here for security groups we have only edit inbound rules. For NAT, we are going to have all the edit inbound and outbound rules. But the first thing is, let us associate it to our subnet. Okay, edit subnet associations. Now here we are going to put it around our public subnet, and we are going to save. Now let us look at this NAC and see what is happening here. You see that the NAC has everything denied. All traffic is being denied. That means at this particular moment, nobody should have access to our website. Nobody, whosoever. The access is denied for everybody. So let us go and see. Actually, let us copy our IP address and paste it. It takes some time to function. It will take some time for it to take effect. Okay, I think our NAC is functioning now. So our website is no more available anymore. Let's see. Our website is no more available. That means our NAT is functioning very well. Okay, our NAT is functioning very well, so nobody has access to our website anymore. Our website is blocked from the general internet. Nobody have access to our website. Now, in order for us to actually make good use of this NAT, they say that it is smart. So what can we do with it? What can we do with it? This is where we come to this our topics here. We are going to come and treat what we call ephemeral ports, and we are going to see deny rules, and we are going to see port numbers, rule numbers. All we are going to take a look at all of them at a go. Okay, so let us see what they are. So in order to make this NACL to be intelligent, what you have to do is now we need to go to our NAC, and then we edit the inbound and the outbound rules. The first thing is I have to edit the inbound rules, because even as this NAC is like this, nothing can enter, nothing, even my SSH will be blocked. Okay, even my SSH will be blocked. You see, I don't have access to it anymore. I have been signed out. I cannot do anything. I have been signed out of it, so everything is blocked. See, no traffic is getting access. Okay, that is to show that your NAC is actually really active. Now, if I want to give access first of all to SSH, let me add a rule. I'll have to come to add a rule, and then I'll have to give an SSH rule. Right, when I give an SSH rule, I want to give that rule only to maybe my computer or to anybody, and then I'll click allow or don't allow. Okay, I'll give allow or don't allow. Now if I put allow, then I am allowed to have access to it. If I put deny, then I cannot get access to it. Okay, now the second thing I'm going to do is I'm going to add another one, which is HTTP and from anywhere, and then I'm going to allow it. Now for these two, I'm going to put a number 100 and put another number 200. Now these numbers, what are they? What are these numbers? Let me get your notes. Okay, here it is. A network access control list contains numbered list of rules that are evaluated in order, starting from the lowest numbered rule to determine whether the traffic goes in or out of the subnet associated with a network access control list. The highest numbered rule can be 32,766, right? It is recommended to create new rules with increments, for example, increments of 10 or 100, so that you can easily add new rules where you need later. So you read about these rules. Let us come and let me show you. Now these rules here, it says that these rules, the smaller the rule, the higher its precedence. That means that what? If I have two conditions and those two conditions are the same, let me say HTTP have two conditions and the two conditions are the same, the smaller rule number will take precedence. It will be more important and only that rule will be affected and only that rule will go to function, which means the higher number will be ignored. Now we'll come to an example of that. At this level, we have given an inbound rule to, change the rule at the level of inbound here. Now we save. Then we have to do the same thing at the level of outbound. You should do both for inbound and for outbound. Remember the first one was 100 and it was SSH and it was allowed. Second one was 200 and it was HTTP and it was allowed. Now the thing is, we have given access now to our web server. Can we now see our web server? We should be capable of seeing our web server. It takes a bit of time to come on. Okay, it takes a bit of time to refresh, so we should be patient enough and see if our web server finally comes on. So while we wait for our web server to come on, let me explain something to you. Now imagine you are the solution architect or the system administrator of your company. There is a colleague who might have been sacked, or his job has been terminated and he has like 2 or 3 days to work in the office before he leaves the office, right? Those type of things happen. You have a colleague whose job has been terminated, but he has at least 3 days before he leaves the office. That type of a colleague, they'll tell you that, please, can you suspend his access from the website and suspend his access through SSH to all your systems? What do you do in that case? If your systems are found inside some sort of a network access control list like this one, what you are going to do is you are going to come to your network access control here, and then you edit inbound rules. Now you put example HTTP, and then you put 99. Be very careful, take a look at what I'm doing. You put 99, and then you put SSH, and then here now, let's just take for example that I was the one. My IP address, definitely you should know your IP address, the IP address of your colleague. I mean, it is a computer that is given in the company, so everybody should know the IP address of all the computers. Here I would look for my IP address. Okay, this is my IP lookup. So this is my IP address here. If I copy this IP address and I come here and I put here, and I put /32 and I say deny, that means that I can never, everybody in the world can get access to this machine through SSH, but me, I will never get access. I have been denied. Safe. I've done it at the inbound level. Now I have to do it at the outbound level. Add rule 99, SSH, my IP address /32 and deny. I save. Now look at something here. This is SSH from anywhere and it is allowed, but this is SSH from my computer and it is denied. So how will this computer know which SSH to deny and which SSH to accept? It will take the lowest rule number. That is the one that it is going to be affected. So their lowest rule number is 99. That means SSH 99 is going to be refused. It will not be accepted. And then SSH 100 is going to be accepted. Okay, so SSH 100 is accepted, SSH 99 rejected, it's denied. So I cannot get access to this machine. Everybody can get access to this machine, but I cannot get access to this machine. Okay, so that is the importance of rule numbers. Okay, now as we have done all this, when you do all this, you discover that your web server is not coming. Why is your web server not coming? Your web server will never come. Okay, your web server will never come. Why will your web server not come? There is this idea of ephemeral ports. Okay, ephemeral ports. These are ports that you must open before your website can come. When you are not using network access control, you don't need ephemeral ports. But when you are using network access control, you must open ephemeral ports. If you don't open ephemeral port, your website will never be accessible. So what is the use of this ephemeral port? The use of this ephemeral port is that there are some hackers that simply go and block your SSH, your HTTP port. You know, everybody knows that most of the web servers use 80 for HTTP. So some hackers can manipulate and block your HTTP port, which is 80, and you yourself, you are unable to get access to your website. Within that period of time, your website is down. So for websites that are not supposed to be down in any way, you should make sure that you put ephemeral ports, so that if hackers block port 80, AWS will automatically provide a port within a certain range. What is that range? Let us first of all go and create ephemeral ports. Let's go to inbound role first, and then we add a role, create our ephemeral port and put it to be the smallest number. You can put it 80, and then custom HTTP. The ports have a range of 1024 to 65,535. That's their range, 1024 to 65,535. Okay, so that means if hackers block this port 80, this one here, this port 80 here, it will be possible for AWS to provide another port for the web server automatically. Okay, that is to bypass what hackers have done. So that is the use of these ephemeral ports. So we have created that ephemeral port, and we just need to save. We go to the outbound rules, and we create our ephemeral port there. We gave what? 80, and we gave 1024 to 65,535, and then we save. Now after we do this, we are sure now that our website can function. Our website comes on live now without any problem. You see how our website comes on live now without any problem. So if we did not provide those ephemeral ports, our website would never have come online. Okay, so we know now the use of our ephemeral ports. We know now how to deny access to particular IP addresses, and we know the use of rule numbers. Okay, we know all this right now under network access control list. So it is a layer of smart security that we use in order to protect our services. Okay, so now we are moving over to our last topic of the day, which is VPC peering. Okay, now we have created one VPC here. We have created one VPC here. Now this is our diagram for VPC peering. We have created all these. We have a VPC, we have a bastion here in this subnet here, and from this bastion in this subnet we are going to enter a database in the private subnet. This is a public subnet, this one, and then this is a private subnet, this one. Okay, now this is what we are going to do. We want to create another VPC, a different VPC, and in that VPC we create a private subnet inside that VPC, and then we'll move from this private subnet into the different VPC's private subnet. that is going to be a huge lot of connection and linking that we are going to do here. Okay, we are going to move from private subnet in VPC1 to private subnet in VPC2. That is going to be what we call true VPC peering. Okay, so what do we know till now? We know that we are here. Let's try to see what we know. We are signed out, so let's sign into, which one is our address first of all? Is it 22? I'm not sure. Should be 89. Let's get the right one. Okay, this is our bastion. Our bastion is planted because we locked out. Oh, I forgot that I locked myself out with from the network access control list. Let me go and remove myself from there. See, my IP is denied here, so let me put allow, save, and go to outbounds. And then I allow and save. Okay, this is the only time when I can have access. So that's how you can use network access control list in order to suspend some of your workers. Okay, we know that we are in our bastion right now, and in order to move from our bastion to our database, what do we need to do? All we need to do is we copy all we need to do is we copy our link of our database and we move. Right, here's our database. You just simply have to copy the link of the database and then we move from our bastion to our database, and we are there. To make sure that you are there, always make sure you check. Here it was 172 and here is 198, so we are there. We are now in our database and our database is having internet connection. Now we want to move from our database to a different EC2 instance in a different VPC. Let us first go and create that VPC, please. Let us create a VPC. Let's put it to VPC2. And then in this VPC we have 10.20.0.0/16. We create our VPC. Now inside that VPC, let us create one subnet, and it is going to be inside VPC 2, and the subnet we are going to call private subnet 2. Private subnet 2. Let's create it in 2A. Now in private subnet 2, let's give it 10.20.1.0/24. Let's copy this and keep. We are going to need it. Create. Okay, now inside private subnet 2, let us create an EC2 instance there. We call it VPC 2 instance. We select our key pair. We decide where it goes. VPC2 in a private subnet, yeah, and we create a security group, VPC -2 security group. And we open SSH port. You can keep it to anywhere, no problem. We create our EC2 instance. Now the question that we have is, can we now move from this database where we are found? Here is where we are found. Can we now just SSH from this database to this EC2 instance? That is the question we want to ask ourselves. Is it possible for us to just move from this database to this EC2 instance? We had a concept. Our concept was that if we do create the key pair of this EC2 instance inside this one, we can use it to just move. So let's go ahead and create the key pair of this EC2 instance inside this database. We are found inside this database. If we run ls, why did we leave the database? No problems. We are going to see. Let's check what the issue is. Our bastion should have get our bastion. Now ls, we have the key pair there. So the next one now is the connection to our database, which here it is vpc1db connect. Okay, we are in our DB. Now the question is, we run ls here, we don't see anything, but we can create a key pair here. We can create this key pair as we said. We can create this key pair and we copy the content of the key pair just like we did, and we come and we paste here just like we did. Now let us try to connect. We come here. First of all, let us change the permissions. Permissions changed. So get a connection to the VPC2 instance. Here you are. This one now is to the VPC2 instance. We try to see if we can connect. Now we are unable to connect. Why are we unable to connect? It is because we are trying to move from one VPC to another VPC. Here we are. We have connected inside this one. We were able to take the key pair of this one and put here, and from here connect to this one. Very easy. But in order to connect from this guy to this guy across these different VPCs, what we need to do is we need to invoke what we call VPC pairing. Okay, we have to pair the two VPCs together before we do it. So what is VPC pairing? Let us see. We are going to VPC pairing is actually a resource under VPC. So come to VPC, you see pairing connections. Click on pairing connections and then you create pairing. You can say VPC 1 to VPC 2, right? And then the requester is VPC 1, and we come down to all of them are in my account. So you can pair from one VPC to a different VPC in a different account, or you can pair from a VPC in a different region. So you take care when you are pairing from a different region to another region, or from a different account to a different account. So for me, I'm pairing within the same account. Now you go to the VPC acceptor, should be VPC 2. So VPC requester is VPC 1, VPC acceptor is VPC 2. Create pairing. Now you go to your VPCs, go to VPC 1 requested, so go to VPC 2. You're in VPC 2, you come down to pairings, connection pairings, you will see one connection pending. Okay, click on the connection. You see you can accept or reject this pairing connection. Request using the actions menu. That means this action menu. So I come to the actions menu and I accept the request. I accept the request. Okay, I have accepted the request. Can we now connect? Still we cannot connect. Why can we not connect? We only paired the VPCs. The subnets are not yet paired. Okay, we only paired these two lines like this, the VPCs like this. The subnets are not yet paired. These other subnets and this one are not yet paired. So you have to pair the VPC and then you pair also the subnet, connect the subnet. How to connect the subnet? You need a route table to be connected to the EC2 here, a route table to be connected to the EC2 here, and then the two route tables connect now to your VPC pairing. That is how you connect. So you take this route table here, connect it here, send it to VPC pairing, take this route table here, connect it here, send it to VPC pairing. Okay, so that is what we are going to do right away. So you go now to creating route tables. Now we create pairing route table, VPC VPC 1 pairing route table. So this one is going to VPC 1. Okay, now you create it. Good. Now you come, it has been created, the route table has been created. Now as the route table is being created, you come to actions, you link the route table to a subnet. Which subnet are you linking? You link the route table to the private subnet, because we are linking private subnet of VPC 1 to private subnet of VPC 2. Okay, good. You have linked the route table to that private subnet. The next thing is you have to route now traffic. Where are you routing traffic? Add route. You are routing traffic to your VPC pairing this time around. You are routing traffic to your VPC pairing. Okay, now where you are routing traffic to your VPC pairing, your traffic will be coming from where? Your destination traffic. Where do you want to send this traffic? You are routing traffic to the VPC pairing, but where are you sending the traffic to? Where is your final destination? You are sending your traffic to the private subnet of VPC 2. What is that subnet? The private subnet of VPC 2, and this is the subnet. Okay, that is where you are sending your traffic, the private subnet of VPC 2. That is the private subnet of VPC2. You are in route table inside VPC1, but you are sending it to VPC2. Okay, we save. The next thing is you create another route table. This one, now you are creating a route table where in VPC2. So this one is VPC2 route table pairing. Now from here you're going to choose your VPC, which is VPC2. Now inside there you're going to create your route table. When you create your route table, now you associate it to the subnet. Which subnet? Private subnet of VPC2. You save. Now you route now traffic from where it is leaving from your VPC2 to where? To the peering, to peering connection. And when it links to peering connection, where is its destination? The destination is the CIDR of private subnet 1. Okay, the CIDR of the private subnet 1. That's the destination. And then you save. Good. If we have done everything correct at this level, we think that we can connect to our VPC. Now VPC is connecting, and we are capable to connect. So look at where we are found now. We are found at this level. We left from the internet, we entered our Bastion server, we left from our Bastion server, we entered our database. Now there was another VPC created, and inside that VPC a private subnet was created there. We left from the private subnet and we were able to create a connection between those two VPCs, and we were able to enter that private subnet, and we are found now inside that private subnet. So this is, if you understand network very well, you can move from one PC to the next PC to the next PC to the next PC to the next PC. No matter how many servers are there, you can move from one server to the other. Okay, so this is what we really have about pairings, NAT, NAC, and network access control list. So at this moment we are capable of saying that we have understood the concept very well. But after you must have done all this, you have created so many things, and this is where the greatest confusion always starts. You have created so many things. How do you start deleting? How do you start deleting? The first way you start deleting is from your EC2 instances. Okay, the first way you start deleting is from your EC2 instances. So you come to your EC2 instances, make sure you delete all of them. You terminate all your EC2 instances. They will take some time to get terminated. They are shutting down. Okay, now all of them have been terminated. So EC2 instance terminated. Second thing, your NAT gateway. Come to your NAT. This is your NAT gateway. Okay, before you first of all do anything to terminate your NAT gateway, they will ask you for confirmation. You've terminated your NAT gateway. Now it is deleting, it is not yet terminated. Okay, Now when you delete your NAT gateway, that is not all. What do you have to do? Remember I talked about elastic IP. So you have to release that elastic IP. If you don't release that elastic IP, you are in trouble. So come down here, click on elastic IP. If you click on elastic IP and you see anything here, that means you are being built. So you click on it and then click on action and then you release elastic IP. It cannot be released because NAT is still being deleted. Okay, NAT has been deleted. So after NAT has been deleted, we can go now and we release our elastic IP. It is having an association, cannot be released with association IDs. So let's see where our NAT was being associated. Okay, let's go and delete our subnets. These are our various subnets. Let's first of all keep subnet, private subnet 2, delete subnet, delete. Now the subnet has been deleted. Let's go now to elastic IPs, release. Now it has been released. So you see the logical way in which you are deleting your resources. Some resources cannot be deleted while others are still there. Okay, it's not possible like that. Now let's go back to subnets and delete subnet of private subnet. First of all, we have to go to peerings and then we click on action. We first release a peering. Actions, yep. Delete all the routable entries, yes. Delete. Okay, our pairing has been deleted. Now the next thing we are going to delete is subnets. The subnet of VPC 2. Delete subnet. If you don't do it like this, deleting your resources will be difficult for you. Now the last thing we are going to do is delete our VPC now. VPC 2, delete VPC. Then VPC 1, delete VPC. It will delete with all of this, its internet gateway and everything that is written here, it will delete with it. So delete VPC. So we have successfully deleted everything. Okay, so that is how you delete your resources. when you finish practice. That is how. Always delete your resources. If you don't delete your resources, you are going to incur a cost, and the cost is going to be very, very enormous for you. All right. So guys, I hope you are going to practice this one very, very intensely. We are going to continue finishing the last parts of VPC in our next video, and then we are going to enter database and go as fast as we can. All right, keep practicing. Do not relent. Keep working hard. Everything about DevOps is practice. There is no reading. Practice and do it. When you do it over and over, it gets easy to explain. Okay, you cannot read something and go and explain in an interview, but when you do it, you explain in an interview in a way that anybody that listens to you understands that you know how to do this thing. All right, so keep on practicing, and we see you in the next video.